Welcome to Data Management for Data Science, focusing on Python data structures, specifically lists. Lists in Python are versatile, allowing you to store sequences of items in a single variable. Imagine you have a list of ingredients for a recipe. You can easily add, remove, or modify ingredients as needed. Lists are ordered, meaning each item has a specific position starting from 0. They support various operations like slicing, which lets you access a portion of the list, and concatenation to combine lists. Understanding lists is foundational for data manipulation in Python, enabling you to handle complex datasets efficiently. Let's dive into how lists can transform your data science projects. Python's standard library is a treasure trove of modules and packages that simplify the creation of powerful and efficient programs. It includes tools for file handling, data manipulation, and networking, all available with every Python installation. Understanding built-in data structures is crucial because they form the backbone of Python's simplicity and efficiency. They offer ready-made solutions for managing data collections, enhancing performance, and ensuring your code is clean and maintainable. Mastering these structures enables you to select the right tool for any task, resulting in faster programming and better resource management. We'll cover key structures like lists, tuples, dictionaries, and sets, each designed to handle data in unique and effective ways. Let's dive in and learn about lists first. Lists are mutable, meaning you can change them, and they're ordered sequences of elements. Think of them as a versatile way to store collections of items. For instance, you can create a list like this. List 1 equal sign 1, 2, 3, 4. Key operations include indexing, where you access elements by their position, slicing to get sublists, and appending to add new items. For example, using mylist.append 5, you add 5 to the end of your list. Accessing elements by index is straightforward. If you have mylist equal sign apple, banana, cherry, date, you can access each element by its index. List slicing is a powerful tool in Python for extracting specific portions of a list. Imagine you have a list and you want just a piece of it. You can do this using the syntax. List bracket start :and : step bracket. Here's how it works. Asterisk, asterisk. Start asterisk, asterisk is the index where slicing begins, inclusive, and defaults to 0. Asterisk, asterisk, end, asterisk, asterisk is where it stops, exclusive, meaning the element at this index isn't included. Asterisk, asterisk, step. Asterisk, asterisk is optional and determines the interval between elements, defaulting to 1. Let's see an example. Given my list equal sign 10, 20, 30, 40, 50, 60, if you slice from index 1, 4, you get the elements with indices 1, 2, and 3. That is 20, 30, and 40. When you slice a list, if you leave out the start index, Python begins from the list start. For example, my list bracket :3 grabs elements from the start up 2, but not including index 3, resulting in 10, 20, 30. If you omit the end index, slicing continues to the list's end. So my list 2 : returns 30, 40, 50, 60, starting from index 2. Now let's talk about slicing with a step. A step defines how many elements to skip. Using my list bracket : 2, you'll get every second element, resulting in 10, 30, and 50. Imagine you have a list, and you want to access elements starting from the end. Negative indices allow you to do just that. For instance, using my _list bracket -2 : -1 slices the list from the second last element all the way back to the beginning. The output, 50, 40, 30, 20, 10, reverses the order as it moves from the second last to the first element. This technique is incredibly useful for manipulating data efficiently, especially when dealing with lists where the structure might change dynamically. Now imagine a list where each item is another list. This is a powerful way to organize data, akin to a 2D array or matrix. Each inner list can represent a row or a set of related information. For example, here's a simple 2D list or matrix. The first row is 1, 2, 3, the second row is 4, 5, 6, and the third row is 7, 8, 9. Now let's see how lists of lists can store diverse types of data. Consider this list. Alice, 24, engineer, represents one person's details. Bobby M. 27, designer, represents another person, etc. So you have a list of lists. When working with a list of lists, accessing individual elements requires nested indexing. Think of it as a two-step process. First, use the outer index to pick the sublist, then the inner index to choose the specific element within that sublist. For example, to access the first element of the first sublist in a matrix, you'd write print matrix 0, 0. This concept extends to multidimensional arrays like an RGB image, where you'll need 3 indices, one for the row, one for the column, and one for the color channel. So, to access a red pixel, use image row column color. This technique is essential for efficiently navigating complex data structures. Today we're tackling a roster analysis challenge. Imagine you have a file with names formatted like this: last, first, middle initial, where the middle initial is optional. Our goal is to extract only the last names, sort them alphabetically, and count how many last names begin with each letter. This exercise is a great way to sharpen your file handling and data processing skills in coding. Before moving to the solution, pause the video and try writing the code yourself. Good luck, and let's see how you approach this problem. Initialization is crucial. It involves setting up your environment, importing necessary libraries, and defining initial variables. This foundation ensures your code runs smoothly and efficiently. In this code, we will name the file with the full path and also initialize a list called last names, which is empty at the moment. Now, let's think about how we open a file with the command open filename as roster. Then we run a loop. For each line in the roster, we read a line, strip the beginning and end white spaces, and if there's an empty line, we skip it. When you encounter a name formatted as last, first, middle, the key is to split it at the comma. Everything before the comma is the last name, which helps in sorting and categorizing names efficiently. Since we only need the last name, we're going to ignore the rest of it. We will append each last name to the end of the list. Python has a really easy way to sort last names. Just take the list and sort it. Now, for each name in last names, the first letter is given by the name at index 0, and then convert that to uppercase to be consistent. The counts by letter dictionary will use the last letter as the index and add 1 to the item with that first letter of the last name. Then we print the sorted last names, and the counts are sorted by the count of the letter. The link to this code is given in comment section. Use your favorite Python interpreter to run the code and see how that works. Good luck, and until next time.